Hello, Rio. The purpose of this video is to give you an opportunity to catch up on missing notes. It's possible we didn't finish them all together. In any event, Chapter 3, start getting into some information that you guys would have covered back in Bio and certainly in AP Bio. So hopefully this next unit is a little bit more fresh. All right, remember I am recording a video. I will not be sitting on the slides as long as I do when we're lecturing. Feel free to pause the video if I'm going too fast, and I will give you a 5-second warning before I do advance to the next slide. All right, here we go. Okay, so we're going to do some abbreviation. Atmosphere is going to be AS, hydrosphere, which is all the water on the planet. It's going to be HS, geosphere. It's going to be GS, and biosphere is going to be BS. So characteristics. The layer of the atmosphere that we live in is referred to as the troposphere. So that's got the air, it's got the pollution, it's got all the clouds, the water vapor, it's got the majority of the greenhouse gases. The next layer up is the stratosphere. That has an ozone layer which filters the sun's UV radiation. And of course, chlorofluorocarbons destroy ozone, and there is a growing ozone hole from the South Pole and Antarctica. Moving ahead in 5, 4, 3, 2, and 1. All right, characteristics of the hydrosphere: all the water vapor, liquid water, ice, any form of water on the planet is part of the hydrosphere. Majority of the water is found in the oceans. Characteristics of the geosphere. So the geosphere is the crust and the inner portions of the Earth. So obviously the upper portions of the crust where we find soils, we find nutrients. Also, the crust does contain all the non-renewable fossil fuels. Characteristics of the biosphere: any living part of the Earth is considered to be part of the biosphere. So the biosphere is found in the atmosphere, hydrosphere, and geosphere. Okay, moving ahead in about 5, 4, 3, 2, and 1. All right, sustaining life. Pick 2 of these. So it all starts with the sun. That gives energy to the producers, which convert carbon dioxide and water vapor in the atmosphere. The reaction is run by the energy found in photons. Nutrient cycling, so the water cycle, carbon cycle, nitrogen cycle, and phosphorus cycles. Gravity holds the atmosphere close to the Earth, which keeps heat near the surface. It also allows for movement of matter in the nutrient cycles. Greenhouse effect. It's a natural process. If we did not have the greenhouse effect on planet Earth, we would not have life evolved, or at least life would not have evolved on the land surfaces. It basically keeps the temperature on the planet relatively warm. Problem with the greenhouse effect is it's becoming more and more efficient, which is keeping more and more heat. And we're the Goldilocks planet. It's just right, but it's getting warmer and warmer and warmer, so it's getting less and less just right. And essentially what happens is shortwave radiation comes in, it makes it easily through the atmosphere, it gets absorbed by some surface on the Earth, and it changes to long wave radiation, which is more easily trapped in the atmosphere by greenhouse gases. Primary greenhouse gases are methane, carbon dioxide, carbon monoxide, water vapor, and to a lesser degree, nitrous oxide and ozone. Moving ahead in 5, 4, 3, 2, and 1. All right, let's use this as an opportunity to practice with your notes. All right, combination 1 or 2, the blank contains important ozone while the blank contains the oxygen we breathe. and all of the clouds. Is that troposphere in the first blank or troposphere in the second blank? Is it stratosphere in the first blank or stratosphere in the second blank? And you might want to take a look back at number 2. All right, correct answer is combination number 2, stratosphere and troposphere. I do a little bit of matching. You'll need to take a look back at number 2, 3, 4, and 5 for this one. All right, so the atmosphere is C, all the gas above the crust. Rock minerals and soil makes up the geosphere, so B for number 2. The hydrosphere is all the water on the earth, so number 3 is D, and the biosphere would be A, all living things. Describe the greenhouse effect and its importance. Take a look back at number 7. So if we didn't have the greenhouse effect, we wouldn't have enough heat in the atmosphere to allow for liquid water to be on the planet, and life would never have evolved, likely. Its importance is it simply allows for the Earth to be a livable temperature. But like I said before, the greenhouse effect's getting a little out of control. It's getting too good at absorbing heat because the things that do the absorbing, greenhouse gases, there are too many of them in the atmosphere. All right, moving ahead in 5, 4, 3, 2, 1. All right, 5 levels of matter. Biosphere. Ecosystem, so this is big to small. We're going to abbreviate ecosystems. Communities, populations, we're going to abbreviate that. And orgs stands for organisms. All right, trophic level. Organisms are classified as producers or consumers based on their source of nutrients. So a trophic level is a feeding level. For example, trophic level 1 is always going to be the producer level. Trophic level 2 is always going to be the first consumer level. The highest trophic level, those are going to be your apex predators at the end of a food chain or the top of a food web. Producers are organisms that make their own energy from converting carbon dioxide and water vapor using the sun into oxygen gas and glucose. And they're also referred to as autotrophs. Autotroph meaning they get their energy automatically from the sun. And glucose, because these are the chemical sugars. They make up the base of all food chains. Not only do plants use that glucose for their own cellular processes, but when producers are consumed, that glucose provides energy for the consumers as well. Moving ahead in 5, 4, 3, 2, and 1. Consumers, so they cannot get their own energy. They're referred to as heterotrophs. Hetero meaning they must get their energy from something different than the sun. And of course, they get their energy from feeding on other things. Primary consumers, or consumers, pardon me. You can be a primary consumer and not be an herbivore. Okay, but an herbivore is a consumer that only eats plants or only eats photosynthetic organisms. Carnivores eat other animals. So a carnivore is described as a consumer that eats only meat. Typically apex predators, top predators are going to be carnivores. Omnivores eat both plants and animals. So most humans are omnivores. They eat a combination of meat and vegetables or photosynthesizers. And again, consumers are referred to as heterotrophs, whereas producers are autotrophs. All right, the last part of food webs are the decomposers. These are consumers that recycle nutrients from wastes from dead plants and animals. The nutrients get returned to the soil, to the water, or to the atmosphere. And the main decomposers are bacteria, fungi, earthworms, and vultures. And also, there's another word that you might come across. It's called detritivore, D-E-T-R-I-T-I-V-O-R-E, detritivore. Detritivores are organisms that only eat dead things. So, for example, a bacteria could actually live off of something that's living as well. So go to fungi. I'm moving ahead in 5, 4, 3, 2, 1. Importance of producers and glucose. The chemical energy is the base of all the food chains. I mentioned that before. Aerobic respiration. So this is when ATP, which is the cell energy, comes from the breakdown of glucose in the presence of oxygen. Glucose can be broken down without oxygen, but you don't get nearly as many ATP. If I'm not mistaken, you get 4 ATP, whereas if you have oxygen, you get 36. So obviously, organisms are able to thrive a lot more when they can breathe and get oxygen. And of course, the reason why we breathe or inhale oxygen is so we can get that oxygen to our cells to get ATP from cell respiration or aerobic respiration. The waste products are carbon dioxide and water vapor, and those consequently are the reactants for photosynthesis. So photosynthesis produces 2 things that are needed for respiration. Respiration produces 2 things that are both needed for photosynthesis. Soil, it's a renewable resource. It cycles very, very slowly. Takes a long time to build fertile soils. And it's a mixture of rock, mineral nutrients, organic matter, water, air, and living organisms, primarily microbes and decomposers. Moving ahead in 5, 4, 3, 2, 1. All right, let's practice with our notes a little bit. What are the organisms who eat other organisms? What are the organisms who use sunlight to make their own energy? You might want to take a look back at number 10, 11, 12 for this. All right, so that'd be combination 1. Consumers eat other organisms. Producers make their own energy. So combination 1's correct. Match them up. Take a look at number 11, 12 for this. All right, so number 1, herbivore. They eat plants only. D. 2, carnivore. That'd be A, animals only. 3, omnivore. Eats plants and animals. B. Detritivore, which is, again, kind of another word for a decomposer. They eat dead things and wastes, so C. All right. Blank, blank is where ATP blank is provided to cells by the breakdown of glucose in the presence of blank. The reason why I have the numbers there is because when we do this as a whiteboard question in the classroom, I would like you to number your answers. You might want to take a look at number 14 for this one. Yeah, so cell respiration is where ATP energy is provided to cells by the breakdown of glucose in the presence of number 3 would be oxygen or O2 gas. Moving ahead in 5, 4, 3, 2, 1. All right, ecosystem. Flows in food chains, which we're going to abbreviate as FCs, and food webs. Food chain is movement of energy and nutrients from one trophic level to the next. And food web is a network of interconnected food chains. So a food web is more complex than is a food chain. Loss of energy. It's lost as heat. It's metabolic heat after every feeding relationship. So if you have 100 calories of energy at the producer level, you're only going to get 10 calories of energy available at trophic level 2 by the consumer. And then you would only get 10% of that. So you'd only get 1 calorie at trophic level 3. So that's lost as metabolic heat. And because there are fewer calories available for the top consumers, That is the primary reason why they have to eat more food, is because it's less efficient to eat at the end of a food chain than it is to eat at a lower level on the food chain in terms of the calories that are available. All right. Moving ahead in 5, 4, 3, 2, 1. All right, importance of lost energy. So I just said that the higher trophic levels are going to need to eat more because they have access to fewer calories. Some energy is in detritus, dead stuff. And metabolic waste is energy for decomposers. Definition of biomass, the total mass of organisms in a given trophic level. You are going to have more biomass in the lower trophic levels. If I'm not mistaken, phytoplankton, in terms of mass for an organism, they occupy, or they have the most mass for any one organism on this planet. And the majority of the oxygen in our atmosphere has come from phytoplankton, which is photosynthesizing plankton. Differences in production. Yes, there are. Some ecosystems produce plant matter faster than others. Depends on how many nutrients they have in the soil. It depends on how much sunlight they're able to get. It depends on how much water is in that environment. Also, to a degree, it depends on what types of plants are growing in that ecosystem. Moving ahead in 5, 4, 3, 2, 1. Which is more complex, a food chain or a food web? You might want to take a look back at number 16. Yeah, so food webs are more complex because they contain many food chains. How much energy is lost during a feeding relationship? What does this mean for higher trophic levels in the food chain or the food web? Take a look back at number 17 and 18. Yeah, so 90% is lost as metabolic heat. Only 10% of the energy available is transferred to the next trophic level. And that means for higher trophic levels, you're going to need to eat more food because you're getting less calories. All right, gross primary productivity. We're going to abbreviate it as GPP. Rate at which an ecosystem producers convert solar energy into stored chemical energy of glucose. Units are going to be an energy unit over an area per time. Net primary productivity, pick two of these. Definitely write down the definition. A rate at which an ecosystem producers convert solar energy to chemical energy minus the rate at which they use the stored energy for respiration. So they've got to use some of that glucose to break down to get their own ATP for their own cells. So the net is what they produce in total minus their own body needs. Different in aquatic versus terrestrial land ecosystems. And it limits the number of consumers, including humans, that can survive on Earth. So because there's only a limited net primary productivity for a given ecosystem, it means each ecosystem is going to have its own carrying capacity, the maximum number of organisms that can survive in that given area. Moving ahead in 5, 4, 3, 2, 1. Microorganisms or microbes. More than 10,000 species of those microbes. A lot of ecosystem services are carried out by them. Digestion, decomposing, helps with immunity. We've actually pulled some compounds out of these things. They're important decomposers. They're phytosynthesizers. They remove carbon dioxide from the atmosphere. They protect some plants from diseases. All right, what is ecological efficiency? The percentage of energy transferred from one trophic level to the next. So like I said, typically 90% of the heat is lost. That's kind of an average. I mean, there are some ecosystems that are more efficient than others. But in general, you can assume 90% of the energy is going to be lost as metabolic heat. And the official name of that rule is the 10% rule. Only 10% of the available energy in a lower trophic level can be transferred to the next trophic level. It's lost as heat, which is the second law of thermodynamics. I'm moving ahead in 5, 4, 3, 2, 1. All right, which primary productivity, gross or net, is more closely related to photosynthesis? Might want to take a look back at number 21, 22. So it's gross. It's gross because that is all of the biomass that's produced by photosynthesis. Net is when cell respiration is removed, all that glucose that gets used for the plant or the photosynthesizer's body needs. Which primary productivity is more closely related to how many consumers can survive? So when I'm a consumer and I'm eating a plant, do I get the gross or do I get the net? You only get the net because remember, some of that energy is used by the plant, some of that energy is lost to the atmosphere in the form of heat. So net primary productivity is more related to what's available for consumers. What rule describes that 90% of available energy is lost as heat during a feeding relationship? Take a look at 25. You got it. That is the 10% rule. All right, you guys, I will see you in the classroom. In just a moment. Trying to stop the video. My goodness.